Look closely into the eyes of a stranger, and you are usually met with the deep, grounding warmth of Earth itself. For the vast majority of our history as a species, brown was the only color we knew. It was the universal pigment of humanity, a protective shield of melanin that guarded our sight against the harsh glare of the ancestral sun. But then, something shifted. In a world of shadows and soil, a new light flickered into existence, a piercing, crystalline blue that should not have been there. It is a color that doesn't actually contain any blue pigment at all, yet it has become one of the most recognizable and analyzed traits in the history of human evolution. If you have blue eyes, or if you have ever been captivated by someone who does, you are looking at a biological mystery that traces back to a single moment in time. You are looking at a genetic glitch that turned into a legacy, and until very recently, we had no idea where it came from or why it decided to stay. To understand the mystery, we have to travel back nearly 10,000 years to a time when the glaciers of the last ice age were finally retreating from the face of Europe. This was a world in transition, a bridge between the ancient hunter-gatherers and the first dawn of agriculture. At this point in history, every human being on the planet still carried the original genetic code for dark eyes. There was no such thing as a blue-eyed tribe or a blue-eyed race. There was only the default setting of our ancestors. But somewhere near the Black Sea, in a lone individual, a tiny spark of a mutation occurred. It wasn't a grand design or a calculated shift for survival. It was a mistake, a molecular typo in the massive library of human DNA. For decades, scientists believed that eye color was a simple game of genetic tug-of-war, a trait passed down through straightforward Mendelian inheritance. We were taught that brown was dominant and blue was recessive, a clean binary that explained everything. But the reality is far more haunting and complex than a high school biology chart. The breakthrough came from the dark, damp recesses of a cave in the Cantabrian mountains of Spain. In 2006, archaeologists discovered the remains of a man who lived 7,000 years ago, whom they named Braña 1. When geneticists sequenced his genome, they expected to find a typical early European. Instead, they found a walking contradiction. This man had the dark skin of his African ancestors, but his DNA carried the unmistakable markers for brilliant blue eyes. He was a mosaic of the old world and the new. He proved that the blue eye did not emerge as a byproduct of fair skin, as we had long assumed. It arrived first, a ghostly vanguard of change that predated the physical traits we now associate with Northern Europeans. This discovery sent shockwaves through the scientific community. It meant that the blue eye wasn't an adaptation to help us see better in the dim light of the North. It wasn't a tool for survival at all. It was something else. To find out what, researchers had to look inside the iris itself, down to the level of light and physics. If you were to take a blue eye and pull it apart, you would find something startling. There is no blue ink there. There is no blue protein. If you could hold the iris in your hand, it would look dull and colorless. The blue we see is a trick of the light, a phenomenon known as Tyndall scattering. It is the exact same reason the sky appears blue. When light enters the iris, it encounters a layer that lacks the heavy curtain of melanin found in brown eyes. The light hits the tiny particles within the eye, and the shorter blue wavelengths are scattered back toward the viewer. A blue eye is quite literally a sky trapped within a gaze. But how did the body forget to produce that melanin? The secret lies in a gene called OCA2. This gene acts like a master faucet, controlling the flow of brown pigment into the eye. For millions of years, that faucet was turned all the way up. Then came the mutation. Scientists at the University of Copenhagen discovered that the blue eye isn't caused by the OCA2 gene being broken. If that gene were destroyed, we would be looking at albinism, a total lack of pigment. Instead, a nearby gene called HERC2 acts as a dimmer switch. In blue-eyed people, that switch is partially turned off, limiting the pigment just enough to turn brown into blue. This is where the mystery takes a truly incredible turn. When the team in Copenhagen mapped the DNA of blue-eyed individuals from across the globe, from the fjords of Denmark to the mountains of Jordan and the plains of India, they found something that defied the odds of probability. Every single person with blue eyes on this planet shares the exact same genetic switch in the exact same spot in their DNA. This is not a mutation that happened multiple times in different places. It happened once. One person, born in the prehistoric mist of the Neolithic era, carried this change for the very first time. This means that if you have blue eyes, you are part of a massive global family. Every blue-eyed person you pass on the street is your distant cousin. You all share a single common ancestor who lived somewhere between 6,000 and 10,000 years ago. You are all carrying the signature of a lone individual whose life changed the visual landscape of humanity forever. But this raises a deeper, more pressing question. If this mutation was just a random glitch that provided no clear advantage for hunting, gathering, or surviving the cold, why did it spread? Why didn't it simply flicker out and disappear with its first carrier? Evolution is usually a cold calculator, discarding traits that don't help us thrive. Yet the blue eye spread like wildfire across Europe and eventually the world. Some researchers suggest it was a matter of sexual selection. In a world of brown-eyed people, the sudden appearance of a sapphire gaze might have been seen as strikingly beautiful, or perhaps even divine. Our ancestors may have chosen blue-eyed partners simply because they were different, because they were rare. This rare type advantage could have propelled the gene through the generations, turning a biological error into a coveted trait. It was an evolution driven not by the need to survive, but by the human attraction to the extraordinary. But there is an even bigger implication hidden in our irises. The story of the blue eye reminds us that our genetic history is not a straight line of progress. It is a messy, beautiful series of accidents. We are a collection of mutations that happen to work or happen to be liked or happen to survive the chaos of time. It challenges our concepts of race and identity. When we look at the man from Braña, dark-skinned and blue-eyed, we see a version of humanity that doesn't fit into our modern boxes. He is a reminder that the traits we use to categorize one another are fluid, shifting through the millennia in combinations we can barely imagine. Today, blue eyes are becoming rarer again. As the world becomes more connected and our gene pools merge, the recessive nature of the blue eye means it is slowly receding from the global population. It is not disappearing, but it is returning to the status of a rarity, a precious remnant of a specific moment in our deep past. So the next time you look into a pair of blue eyes, don't just see a color. See a 10,000-year-old traveler. See the sky scattering across a cellular landscape. See the fingerprint of a single ancestor whose name is lost to history, but whose legacy is written in the very light of your vision. We spend so much of our lives looking for meaning in the stars or in the pages of history books. But sometimes, the most profound story of our species is looking right back at us from the mirror. It is a story of a single mistake that became a masterpiece, and a single human being who gave a new color to the world.